VLSos here. This is a video lesson on the properties of quadratics and the vocabulary that we use to refer to the attributes of quadratics. What makes a function or an expression or an equation quadratic? The fact that it has a squared term. And that square, meaning a power of 2, is the highest exponent in the expression. If you had a term that had a power of 3, it wouldn't be quadratic. We might call it cubic. So a quadratic equation is one that has a squared term, and that square is the highest exponential value. The parent quadratic, or the equation that is the simplest possible form of quadratic, is the equation y is equal to x squared. No more complicated than having that squared term and nothing else. The parent quadratic graphs, we could use technology, or we could use a table and plot points, but I'm going to draw it quickly. The graph of the parent parabola looks like this. And we are going to use some vocabulary to describe this graph, as well as all quadratics. The name of the graph of a quadratic equation is a parabola. And all parabola have certain reliable features. Parabolas have an orientation, and that orientation must be up or down. It cannot be left or right. Parent parabola is open up. It's like a bowl that would catch rain if it fell into it. A parabola always has a vertex. The vertex is the lowest point if its orientation is up, and the vertex is the highest point if its orientation is down. We could also call them minimums and maximums. Parent parabola has a minimum or lowest point at the origin. A parabola has branches. The branches are formed by reflection through a vertical line through the vertex. This branch is a curve that is congruent or the same shape as the other branch on the other side of the vertex. It has reflection symmetry. The vertical line, in this case the y-axis, the vertical line that goes through the vertex is a line of reflection symmetry where one branch can reflect across this line to lie exactly on the other. And a graph of a quadratic has x-intercepts and a y-intercept. Typically, a quadratic will have two x-intercepts where both of its branches cross the x-axis. The parent quadratic, or this parent parabola, only intersects the x-axis once at the origin. Some parabolas, if you can imagine this one shifted up, may not intersect the x-axis at all. But a parabola will always have one y-intercept. We can transform the parent quadratic in an infinite number of ways to get other quadratic functions. I'm going to provide an example here. This equation is quadratic because it has a square, and the square is the highest exponent. We can see that there are numbers that have transformed this equation. We've subtracted 3 from x. After squaring, we're multiplying by 2 and a negative, and we're adding 2. This parabola has been transformed in many ways, and with some technology and some knowledge about transformations, we could graph it quickly and we can talk about this parabola that's been transformed or has this equation with all of these terms. We call this graph a parabola. Its orientation is down. Its vertex is located at the coordinates 3, 2. It has branches that are symmetrical about the vertical line that passes through that vertex. It has two x-intercepts, one at 2, 0, and a second one at 4, 0. And it has a y-intercept that could be calculated or found to cross if we had or could show more of the graph into the negatives.